Good morning. Okay. Good evening, ladies and gentlemen. So it's show time, and our two-day workshop on object-oriented design and design patterns live begins now. Okay, and I will be here, and I will be giving a brief intro about the whole workshop. And later on, Mr. Shashi Bhushan will take over, and he will be guiding you about the whole concept of object-oriented design and how will it help you and the uses of the same. Okay, so let's take a look on the topics. So on day one, we will be discussing object-oriented design, its importance and its usefulness, basic concepts, design principles, intro to design patterns, and simply factor pattern. And later on, we will go for the Q&A session. On the day two, we will be going for facade pattern, flyweight pattern, LLD interviews, LLD problems. We will be discussing two problems on LLD, designing a parking lot and designing a movie ticket booking system. At last, we will be sharing some resources for learning LLD. And at last, we will end it with a Q&A. Okay, guys. So there's also a surprise. So everybody who sticks with us till the end of the workshop, till the end of the two-day workshop, will receive something, an amazing surprise from Geeks for Geeks. And there are many people who are asking whether there will be any certificates for this workshop or not. So I have a simple question for you. Write in the comments what is more important for you, skill or certificate. um, we will be deciding whether we will be offering the certificate or not, and we will definitely announce it on tomorrow. I see everybody in the comments is writing skill. So we will definitely offer a certificate for providing their valuable time and opting for skill. I know that's a bit being hypocrite, but you know, I'm very elated that you guys chose skill over certificate. Secondly, have you guys heard about the Geeks for Geeks Premium? We have a newly launched product called the Geeks for Geeks Premium. It's an ad-free model of our Geeks for Geeks blogging website. Okay, the whole blog, the whole content. You're getting the whole content for um, without any ad. Okay, so we will discuss more about this at end of this session. Now I will ask Mr. Shashi to take over and start um, giving you guys some good knowledge. And as you guys chose skill, so you will definitely learn some really good skills today. Okay, guys. Mr. Shashi. Good evening, sir.
Yeah, good evening. Hi, how are you?
I'm good. I'm good. The guys, everybody is elated. They're elated to join this workshop. And did you see the comments? There were like tens of thousands of comments. I guess there are many people out there. It's amazing.
Yes, yeah, it's really
Okay, so
interesting.
I
So,
will, yes, sir. I will just hand it over to you now, and please go ahead and there are 885 are watching now. Okay, great
right.
then.
Okay. Let me start with my short
Sure,
intro.
sir.
Yeah. So I'm Shashi, and currently I'm working with Geeks for Geeks as tech lead and mentor. I teach multiple subjects like DSL, Go, this design pattern, and Java backend thing. Before joining Geeks for Geeks, I was part of Adobe Sign. which is part of Adobe Acrobat. So using Adobe Sign, you can send a document for e-signature. So I was part of that solution. I was mainly in backend, but I have worked on frontend as well using React, and in the backend we were using mainly Java, Spring, and Spring Boot things, right? I was there for 2 years, and before joining Adobe, I was part of Paytm Wallet team. Again, I was in backend, and I was mainly working on Java and Spring things. But apart from that, I worked on JSP and servlet old things as well, right? Uh, okay, so today we'll talk about. Let me share some PPTs with you so that I can teach you easily, right? Let me quickly share my screen. Uh, okay, I hope you are able to see my screen. Okay. Okay, looks like my voice is too loud. Uh, okay, fine. Uh, okay. So today I'll talk about like what is object-oriented design and what is its importance, its usefulness, and why it's important to be a good developer. Apart from that, why it's important for cracking the interviews of for SD1 role or for SD2 role. In fact, in some SD3 interviews as well, they can ask questions on these things. Right. Yeah. So, and then I'll talk about the basic OOD concepts like inheritance, polymorphism, and what is the benefit of using those things and how we can apply those things to solve something, right? And then I'll talk about the design principles like solid. Okay. Uh, Apart from that, I'll start with the design patterns, like what is design patterns and how we can apply them to solve a problem. And then we'll talk about simple factory pattern. Right. So that's the agenda of today's lecture. Tomorrow, I'll talk about one very common pattern, which is facade pattern. Then we'll talk about flyweight pattern. Then I'll talk about like what you can expect in the LLD's rounds, right? Uh, and questions like designing a parking lot, designing a mode ticket booking system. So that's the idea. In last, I'll share some resources from where you can learn all these things, right? So let me start with the session. Okay. Let me quickly check if everything is fine. Just let me look at the comments. Okay. Sounds good. Okay, if I talk about like what is object-oriented design paradigm, right? So again, there are many programming paradigm like structural, then we have functional, then we have OOP, which is object-oriented programming. And again, the benefit is it can make your code easy to change, easy to maintain, right? So let me talk about the benefits of using this paradigm, like why it's so popular. And all the languages like Java, Python, JavaScript, C++, C Sharp, all these languages are based on object-oriented programming, right? So, uh, so let's see like what is the benefit of using this design, like why using the concepts of OED make our design better, make our code clean, right? So some of the benefits of using this design is, again, see the meaning of software is it is software, which means it's easy to change, right? So if something is not easy to change, that means it's not a software. So the idea of software is it should be uh, easy to change, right? I mean, you should be able to change the features easily. If it's taking a lot of effort, if it's not easy to change something, that means it's not a well-designed code, right? Okay. Uh, Apart from that, See, maintenance means adding some new features or existing, fixing the existing bugs, right? So maintaining means basically, let's say if you're not adding a new feature, still you should be able to fix the bugs, or you should be update the things, right? So if your code is not easily maintainable, that means there's something wrong with your design. So if you're using these patterns, if you're using these principles, if you're using these concepts of OOD, your code will be maintainable. You can easily maintain your code, right? Then the third thing is testability, right? Like how easy it is to test your code. Let's say if you have a really large piece of code and uh, just wait for 1 second. Okay. Um, so let's say if you're really large piece of code, and let's say it's taking a lot of effort to test the code, right? And let's say if you're making a very small change in one of the modules of your code, and in that case you have to test your the whole code, right? That means your code is not well designed. You are wasting a lot of effort in testing, right? So if you're changing something, if you're fixing a bug, or if you're adding a new feature, or if you are I mean changing anything, in that case you need not you should not test everything, right? So your code should be designed in such a way that you should test only those modules which are affected, right? So if you are testing everything all the time, that means your code is not well designed, right? So these principles will help us to make our code easily testable, because testing is very important, right? And it will take a lot of effort if it is not well designed. So if we are applying all these things properly, we'll be able to test all these things easily, right? So that's the idea. Second thing is, okay, so when we write a code, right, so that code will be read by many developers. Let's say if you're building something right from scratch, so of course you might leave the team, you might leave the company. So many developers will come and they will join the team. They will be working on the same product. So they will have to study the code. They will have to read the code to understand, like, okay, what is going on and how things are implemented, right? So if your code is not easy to understand, if new developers are taking a lot of time to understand your code, that means you have not designed your code very well, right? Okay. So okay, so the one thing that you can do is, if you're using all these things properly, your code will be easy to understand, right? So that's the idea. Modular is again related to all these things. So if your code is modular, your code will be easily maintainable. Your code will be, I would say, easily testable. Your code will be easy to understand, right? So the benefit of modular is, if you're changing something in one module, other modules will be unaffected, right? So that's the idea. Then these things will make your code reusable. Let's say if you're writing some block of code, so if some other components, some other modules can reuse them, that is a really good thing, right? So your uh, design should be reusable. So these are the benefits of using this paradigm, right? Uh, and if we talk about, like, what is object-oriented paradigm, it is nothing but, if you code using object, right? If we talk about object in classes to write a code, so that paradigm is called object-oriented design, right, or object-oriented programming. In a structured program like C, we don't have classes, right? Like in C, you don't need a class. You can uh, write a code. You can build something without creating a class, without creating an object. But if you're using, let's say, C++ or Java or other languages, you will have to create a class. And of course, like in C++, you can build something without or with a class, right? But in Java, you can't write any code without a class, right? So, or without getting an object, right? So in object-oriented programming, we talk about object, and we talk about interfaces. We talk about these concepts like inheritance, polymorphism, encapsulation, abstraction, and we use all of these things to design a beta system that can be easy to maintain, easy to test, easy to understand, right? So let's see some of the concept, right? Okay, so if you talk about the basic terms like object in classes and inheritance, then polymorphism, then abstraction, encapsulation, association, then aggregation, composition. Actually, we don't have that much time to discuss everything. So what I'll do is I'll talk about inheritance, I'll talk about encapsulation, and of course, I'll be sharing some good links with the help of which you can learn the remaining topics, right? So let me talk about these two things, inheritance and encapsulation, right? Okay, right? So that's the idea. Uh, so let me quickly talk like what is inheritance and how it is useful. I mean, what is the benefit of using inheritance, right? Just wait for 1 second. I'll okay. I'm just seeing comments if everything is fine, going fine or not. Right. Let me draw something and explain like what is the benefit of inheritance, right? So in inheritance, what we do is a like we'll have a base class, right? Let's say we have a base class A, and if another class called B is inheriting that class A, in that case, all the code within class A can be inherited in the class B, right? So basically, or let's say if we have one more class called C, right? And if we have some lines of code in the class A, and if class B and class C are inheriting them, in that case, uh, in that case, everything which is present in this class A will be present in class B without writing there. Okay, let me show you one example. Like let's say we have one base class called animal, right? Okay, let's say uh, we have the classes like let's say in the animal base class we have fields like color of the animal or name of the animal or let's say height and then let's say weight. So let's say these are the fields of the animal, right? Uh, okay, and let's say if we have a class called cat which is extending the base class called animal, okay, that means the code which we have written in the animal class will be I mean can be used in this class cat, right? Like we don't need to write the same code in this class as well, right? We can simply write okay, cat extends animal and all the properties of animal class will be part of the cat class, right? Similarly, if we have a class called dog, all these things like all the this thing like color, name, height, weight, all these parts will be part of. I mean, all these attributes will be part of the dog class itself. So this is how we are reusing the code, right? Like we are writing the code at a single place, right? And the same code is being used at multiple places. Like we are using the code. I mean, in this class, then the same code is being used in the dog class. The same code is being used in, uh, let's say, we have a more class called LAN or something, right? So basically, we are writing code at a single place, and the same code is being reused in multiple classes, right? So this is how using inheritance we can reuse the code. Let me quickly talk about like how we can. So let me briefly discuss this thing once again so that you can understand the advantage of inheritance easily. So, okay, like let's say we have a class called dog, and fields are name, height, weight, and color, and then we have the setters, methods, and getter methods, and then we have a constructor. So basically, we have some 40 lines of code in the dog class. Let's say I want to create one more class called cat. And the good thing is that in cat class also we have similar features, like we have similar fields, like uh, just wait. Basically, in the cat class also we will need fields like uh, color, height, weight, name, right? Can be cat. I mean, see, all these fields can be part of the cat class as well, right? That's why what we are doing is uh, I just copied everything from that dog and written in the cat class, because all these things are part of cat class as well. Right? Let's say if I'm going to get, just wait for a second. Okay, let me check the voice quality. Just wait for 1 second. Uh, I'm using another phone. Okay, I hope I'm audible. I'm audible now. Okay, so it looks like some issue with the earphone, so I have changed my earphone. I think things should be fine now. Well, okay. Okay, thank you. Actually, that was not working, so that was not working. Looks like some issue with that. Okay. Uh, hmm. So basically, we are using the same code. We are writing the same code in the cat and dog class, right? So that is the so the issue with this code is we are not reusing the code. We are copying the code. We are duplicating the code. That's not a good design, right? And let's say if I want to add one more class like lion or elephant, in those classes we'll have the same code, right? So what we are doing is we are duplicating the code in multiple classes. So it's not a good design. We are not reusing the code. We are not writing code at a single place and we are not reusing them. So to solve this problem, we have something called inheritance. Right? So what we'll do is we'll have a base class. We'll have a parent class called animal, and we'll write all these things in the base class called animal. And okay, and we'll have all these codes at a single place, and all these classes like dog and cat will be reusing them, right? So that's the idea. So let me create one class called animal. Let me copy all those things in this class. Let me delete this constructor. Well, now what I can do is I can simply delete all these things. Like I don't need to write this code here. I don't need to write, let's say, this thing here. So these classes can simply extend the animal class, which is the base parent class. Uh, and let's say if I want to create one more class called uh, man or something, and this class can simply extend the base class called animal. So what we are doing is we are writing everything into a single place, and all these classes like lion, cat, and dog are reusing the same code, right? So this is how inheritance is helping us to reuse the code. Okay, so the advantage of inheritance is we can reuse the code. Again, in C++ we have a different syntax to implement that. Like this is for Java. Uh, in Python also you can do that. In JavaScript also you can do that, but syntax is different, right? But the idea of inheritance is we can reuse the code, uh, using these things, right? So let me know if you are not able to understand this thing so that I can, I can talk about other things. If not, if it's not clear, then I can discuss some more. I can show you some more examples. So you can let me know if it's not clear so that I can move to the next topics, or I can. Uh, okay. Yeah, looks like it's clear, right? Great. Of course, I won't be discussing all these things because it's too basic. But the idea was if actually see we have audience from multiple backgrounds. Like someone is from college, so he might not be aware of this thing. That's why I thought to start with very basic thing. Great. Now let me quickly talk about. So I can discuss the next topic, encapsulation, or I can start with solid if all of you are already aware of these things. We can quickly let me know if. Uh, okay, so all of you are saying that okay. Okay, okay. Now let me start with the solid. Great. Okay. See, I'll be sharing some links if you are very new to all these. I mean, who do you think that you can learn all these things all these things like abstraction, association by yourself? I won't be discussing all these things because again we have limited time. So the idea is I'll be discussing some selected topics. The next is okay. So in object-oriented design, these are the basic concepts, and all the patterns and all the principles are based on only all these things, right? Like let's say if you're using pattern like observer, or let's say if you're using pattern like a strategy. In all those patterns, we'll be talking about like how the classes and objects are interacting with each other, how we are using inheritance to make our uh, design reusable, how we can use abstraction to make it easy to understand, right? So basically, in all those patterns, we use all these basic concepts, right? Uh, then we have again we have some principles as well, like solid, then dry, then delegation. So I'll be talking about solid, like what is solid principle and how it is useful. Okay. So let me start with solid, and then we'll start with the design patterns. Right? So that's the idea. Okay. Solid is it's an acronym for 5 design principle. Like so in solid we have 5 letters SOLID. So S stands for single responsibility principle, which is SRP, single responsibility principles. So S stands for this one. Then the second letter O stands for open closed principle. Okay, it's OCP, open closed principle. The third is Liskova substitution principle. So the L stands for LSP. Then the fourth one is uh, interface segregation. Okay, and the D stands for dependency inversion. So I'll be talking about SRP, the single responsibility principle, and then I'll talk about dependency injection. I mean dependency inversion. While talking about dependency inversion, I can talk about dependency injection and IOC as well. Okay, so yeah, actually, I mean we don't have that much time to discuss everything. So my plan is I'll discuss the first one and the last one, and the remaining things you can study by yourself. Okay. So let's start with SRP, single responsibility principle. Let me quickly. Okay, I'll be sharing PPT as well. Yeah, so the video will be there on YouTube. So basically, it's a live, video, and it will be there on YouTube after once we are done with this live session. Okay. Yes, I can share the PPT. So I can share the PPT on Google Drive, and I can share that link in the comment, so you can find the PPT as well. Okay, I'm starting solid. Don't worry. Okay. Uh, Let me quickly start with solid. Hmm. Sorry. So we have one thing called uh, SRP. So in solid, S stands for SRP, which means single responsibility principle. That means a class should not be doing multiple things. Like a class should have a single reason to change. Okay. Uh, like, so the simple idea is a class should not be doing everything, right? Okay. uh, like let me talk about this thing with one example. Like, let's say we have a class called user, and let's say the fields of this class is like let's say, sorry, id. Then let me open a new page. Okay. So we can have a class called user. Let's say the fields are id, then name, right? And within this class we have methods, setters, and getter methods of these fields like name and id. uh, and again, it can have other methods, like, you know, methods like, okay, so let's say in user class we have fields like id, name, and its setters and getters. And let's say we have one more method called save to db, save to database, right? And in this method, what we'll be doing is we'll be creating the connection with database. So we'll have some code which will create the db connection, right? Then we'll have some more code that can insert that user to the database table. So we'll have, let's say we have a table, user table in the database, and we will be writing some code to insert that user object to the user database table, right? So, so we'll have some code that will be interacting with the database to insert that user object to the database, right? Okay. So if we are writing all these things, I mean, if you are designing something like this, it has some issues, right? Because here this user class is doing a lot of things. Like, ideally a user class should be doing only one thing. Like, it should be encapsulating the details like id, name, and other things. It should not, it should not have a method like save to database, right? Like, this single class should not be doing everything, because here this user class is only doing things like it is interacting with databases, right? So this is not a good design because it is not following SRP. Here, a user class is not doing only one thing. It is doing multiple things. It is responsible for multiple things because it is interacting with databases as well, right? So let's see what is the issue with this code. What is the issue with this design? Okay. So can anyone tell me, like, what is the issue with this code or design? Like, what can go wrong if we are writing code like this? Anyone? Don't worry, I don't have a lot of PPTs, so don't worry. Okay, multiple problems are addressed, but that's the good thing. So what is the issue with that code? Not maintainable. Okay. Yeah, it's not maintainable. That's true. Yeah, no separation of concerns. That's correct. Okay. Let's see what is the issue with the code. Okay. Uh, it has multiple reasons to change. Let's say if in future I want to add one more feature, like let's say I want to add email ID in this user class, then also I'll have to change this user class. Okay. Or let's say if I'm changing the database, let's say currently I was using MySQL and now I want to use something like MongoDB, right? In that case, we'll have to change this code. Like we'll have to modify this method. Okay, like we'll have to, or let's say if you're, if we are changing the MySQL server as well, in that case also we'll have to change the code so that we can connect to the new MySQL server. So basically, if we are changing anything related to database, in that case we'll have to change this class, right? Which is not a good thing. Ideally, when we are changing anything related to database, this user class should not be affected. This class should not have any change, right? But here, the bad thing is that this class has multiple reasons to change. Like if I am adding fields like email ID, in that case also I have to make a change in this class. If I am changing something in the databases, in that case also I have to change this class. So it's not a maintainable code, right? Because I'm changing that class again and again, right? Okay. So ideally, what we should have is we should have a separate class called user, which will have fields like ID and name and email ID and other things. And then we should have another class called, let's say, user repository or something. Okay. And of course, we should have another class, database manager or something. So this class will have some methods with the help of which you can connect with the database. So this class will be responsible for connecting with the database. This class will be, so again, in this user repository, we'll have some methods which can, so in this class, we'll be using this database manager so that we can use, we can interact with MySQL database or any other database, and we can uh, store a user, or we can search a user, or we can update, let's say, email ID or mobile number of a user, right? So this class will be responsible for interacting with MySQL database with the help of this database manager. This database manager will have some code with the help of which you can connect with the MySQL, right? Okay. So here the good thing is that, let's say, if I'm changing the database, only this class will be changed, right? This class will not be affected at all. This class might be affected, but but if we are designing things in a good way, in that case, this class will also be unaffected, right? But yes, this class will be changed. Or let's say if I'm adding an email ID, or let's say if I'm adding any field in this user class, then this class or this class will be unaffected. So basically, if we are, if one class is responsible for doing only one thing, uh, again, the good thing is it is easy to understand, like because we have the modular code, we are not doing everything in a single class. So it's easy to understand. If, let's say, if a new developer is going to read the code, they will be, they will be happy to read the code. Like it's easy to understand this modular code. And the second thing is it's maintainable, because when we are changing one class, other classes are not affected, right? Okay. Or again, SRP is not only about classes, it's also about modules, right? Like let's say, so module means you can consider them as a package which can have multiple classes, right? So let's say if we are, if we have a single module and it has a lot of classes, it has a lot of codes, in that case, if I'm changing anything, in that case we'll have to test everything because everything is being changed, right? But if we have modular code like this, like one module is responsible for doing one thing, in that case if I'm changing this module, in that case other modules will not be affected. So in that case we don't need to test all these modules. Okay, so these things will make our code easy to test as well. Okay. Yes, that's the idea. The simple idea of SRP is the classes should not be, there's one term called God class. So God class means a class which can do anything, right? So your class should not be God class. Like your class should not be doing everything. So that's the idea. We should have small classes that will be doing multiple things. If you know Java, Uh, okay. So in Java, there are more than 5,000 classes, right? Okay. And the reason, okay, if I talk about only one concern, like if I talk about file handling, in file handling as well, there are more than, I would say, 30 to 40 classes that are responsible for the file handling thing. So the idea is there, I mean, in Java or any framework or any language, we don't have a single class which is doing everything. We have other classes which will be doing single things, right? Like let me show you quickly the classes in Java which are great. I mean, if we can search like Java class file handling, you can see a lot of there are a lot of classes, right? If I can, sorry, let me quickly. I just want to show you one thing, like why we have so many classes in Java or in any framework. Like let's say if you're using Spring or anything, then you will have a lot of classes, right? I can easily. Okay, here we don't have those. I can open the Oracle doc so that we can have classes at a single place. I mean, if you have some time, then you can simply explore like how many classes are there in Java for file handling. There are more than 30 classes. We have a class like writer. We have a different class called file reader. So in fact, for reading and writing as well, we have two different classes. Like we don't have a single class which is doing both the things. Of course, we have classes which are doing things, like which are doing both the things. But in Java, we have a separate class called file writer or file reader. If you know. This class is only responsible for reading a file. Okay. Similarly, we have one more class called file writer, which is responsible for only writing a file. So the idea of these classes are, I mean, they follow SRP. They don't do everything, right? So we have a separate class for reading a file. We have a separate class for writing a file. So the idea is, I mean, if we can compose, I mean, if we can decompose our system in multiple classes, and if a single class is doing a single thing, that's a good design, right? So the basic idea is a single class should not be doing everything. I hope you got the point. If it's yes, then you can let me know. And if it's clear, then you can let me know. I'll go to the next topic. Okay, great. Uh, okay, the next topic is the let's just talk about SRP, single responsibility principle, which is a class should have only one reason to change, which means a class should do only one thing. It should be responsible for only one task, right? Then the second thing is, I mean, the last thing actually. So in Solid, uh, I'm not going to talk about other principles like open close or I'm going to talk about the last one, which is dependency injection. It's an interesting one. While discussing dependency inversion, I'll talk about dependency injection and other things like IOC. Great. So let me quickly talk about like what is dependency inversion. dependency inversion. Okay. So the simple idea is the high level modules, the definition from uh, the book called Gangs of Four, and this is given on Wikipedia as well. So the simple idea is the high level module should not directly depend on low level modules. Okay. So let's understand like what is the meaning of high level module and what is low level module and how and what module is directly dependent on low level module, right? And so we'll understand like what is this and what is the issue with this design, and then we'll see the better version of this and the solution of this problem, which is using dependency inversion. And when we'll use dependency inversion, high level modules and low level modules, both of them will depend on an abstraction layer. So we'll have an abstraction layer which will on which these two modules called high level and low level modules will depend, right? So let's see what is high level module and what is low level module. So let's say if I have a class like notification system, right? And let's say in this class, I have one method called send email. Then one method is send SMS or something, right? And let's say in this method, we have some code that will send the email to the recipient, right? Similarly, in the send SMS method, we'll have some code that can send SMS to the user. Okay. So of course, we'll be using some classes. Like let's say in Java, we have a class like email sender, which will send email to a user. Or let's say in the send SMS method, we have some other class which can send SMS to a user. So in this method, we'll be using the object of that class, like email sender class, and we'll invoke some of the methods, and that method will send the email. Similarly for SMS, we can let's say we have a class called SMS sender, which has a method called send SMS or something. So basically within this method we'll be calling that method of that object, right? So if you can see, this notification system class is using the email sender class and SMS sender class, right? uh, they're using this class is using these two classes to send SMS or to send email, right? So for this example, this is called high level module or high level class, and this is called low level module. This one and this one, both these classes are called low level modules because module is using these two classes to get something done, right? Okay. So that is the basic meaning of high level module and low level module. Uh, Let me now talk about like what is dependency inversion. Okay, so if let me talk about another example, and then I'll show you like how what is the issue when a high level module will directly depend on a low level module, and how dependency inversion can fix that issue. Okay, but I hope you got the meaning of high level module and low level module, like what is these two things. Okay, let me quickly. Uh, okay, let me show you one more example which can help you. Let me write some code that might help you. So let's say we have one class called manager. Let's say within this class, I have an object of worker. We have one more class called worker, or let's say we have one class called simple worker. simple worker. Let me create that class. If you are not aware of the basics of OOPs, in that case you might not understand this thing, because I mean to understand this dependency inversion, you should know the basics of OOPs, like what is inheritance, what is abstraction. Then only you'll be able to understand this one. The idea of this session is just to you know explain like what are the things in uh, OOD and what are the topics that you should learn in design patterns and how they are useful to design something, right? So that's why I'm discussing some topics which are not basic, right? And to understand this thing, you should have a basic knowledge of those concepts like abstraction and composition, right? So here manager has an instance of simple worker, which is a simple composition. And let's say there is one method called uh, get work done, right? And in this method, we can simply invoke uh, one. Let's say worker class is a method called work. Let's say yeah. So let's say in the simple worker class, I have a method called. Let's say we are simply printing something, right? Great. So basically, I mean, if you can see this class, this manager class is nothing but the high level module, and this worker class is nothing but the low level module. This design in this example, the high level module is directly dependent on this low level module, which is the worker. Okay, let's see what is the issue with this design. So let's say there's one more type of worker, which is super worker, and the super worker, again, super worker will have a method called work, right? And in that, let me copy the code from here. Great. Basically, what I'm doing here we are simply working very fast. So super worker can do something at good speed, right? Okay. So currently manager is using the simple worker to get something done, right? Let's say in future, if the requirement is uh, like let's say if the manager needs to get something done by that super worker, in that case we'll have to change the code, right? We'll have to write something like this. Let's say this thing, and then we can write like this super worker. We can create the object like this. And in this method we can simply invoke the work method of that super worker, right? Okay. And let's say again if manager wants to change this worker, in that case also they will have to uh, change the code, right? So if high level module is directly depending on this low level module, in that case we'll have to change code all the time if I want to change this low level module for some reason. Okay. So this is the issue with this design. And the second issue is uh, okay, like let's say like here we are creating this object, right? So if there is a change in the constructor of this superworker class, in that case I'll have to change this code as well. I'll have to change this line as well, because I'll have to pass some fields in the constructor, then only we'll be able to create that object. So if we are creating this object within this class, in that case we'll have to uh, we'll have to make a change in this class, because we if we are changing the constructor of this class, right? So again, this code is not maintainable because we'll have to. Okay, so basically this manager class is tightly coupled with this worker class, right? So if I'm changing anything in this class, in that case, I'll have to change this class as well, right? So they're tightly coupled, uh, which is not a good thing, right? So classes should be lowly coupled, classes should be loosely coupled, so that if we are changing something in one class, then other classes should be not affected, right? But here, that's not the case. If I'm changing the constructor of this class, in that case, I'll have to change this one. So that is the another issue. I hope you got the idea of like what is high level module and what is low level module and how it is not a good design. Then I'll talk like, okay, how dependency inversion concept can help us to fix this issue. So let me know if you are able to understand uh, these things. Okay, looks like some of you are not getting anything. See, the idea is if you are okay. Yeah, so these topics are not base for basic, so I can. Okay, some of you are looks like some of you are able to understand these things. Anupriya, this is part of design patterns actually. So to understand design patterns, you should know like what is these things, right? Okay. So anyone who understood this thing, uh, like what is low level module and high level module. Actually, we have a mixed audience, right? So in that case, uh, okay, some of you are able to understand that. That's good. Okay, but most of you are not able to understand this, right? So okay, so let me do one thing. Okay, let me quickly talk about the like what is dependency inversion, and then I can talk about then I'll start with the region patterns, right? So I'll start the region patterns in 10 minutes. That won't take much time. Okay. Right. Okay. So to fix the issue, what we can do is uh, we'll create one abstraction layer. We'll create one interface. So let's say we have one interface called worker. Right. We have and then these two worker will implement that base interface called uh, interface. Now I have one abstraction layer which is I have one interface called worker, right? And these two classes called simple worker and super worker are like both of them are extending, implementing the base interface, right? So let me draw the diagram so that you can understand things easily. So right now we have a class called manager, right? The idea is manager is the high level module in which I need I want to use the classes like uh, super worker and simple worker. Let's say super worker and simple worker, right? And now both of them are using the interface called worker. So here we have the simple worker class, right? And here we have the super worker class, and both of these classes are implementing the base interface called worker. And now the manager class will have and dependency on this worker class, right? Okay. Okay, let me write some code, and then I think things will be fixed. I'll start patterns quickly. Okay. Okay. Now in this class, instead of creating an object of worker, I'll have interface thing worker, right? The type of this worker will be the base class or the interface called worker, right? And then I'll have a getter method, set worker, like this. So now if I want to change, if I want to use simple worker, I can simply call this method set worker, and I can pass the simple worker. Then I'll be able to create the simple worker. I'll be able to initialize this worker as simple worker. If I want to use super worker, I can simply create, I can simply call this method with an object of super worker, right? So to change this thing, I mean to change or to switch from super worker to simple worker, I don't need to change this code. I don't need to change this class manager, right? Uh, if I can write some code in the main class, let me show you. So this is manager. Let's say here we have a simple. Similarly, let's say I have one more worker called super worker, worker 2, which is now let me create the manager object. Now I can simply pass manager dot say worker one, right? And when I call manager dot get work done, it will call work method of super worker, simple worker, right? Because currently the worker is simple worker. Now without changing the code in manager class, I can change this thing, manager. And I can again call that method, right? So when I'll call this method again, it will call the work method of super worker. Without changing the code in this class, we are able to use both the things. And the second good thing is that if you look carefully, if I'm going to change this class or this class, if I'm going to change the constructor of this class or this class, I don't need to change this class, right? Because we are not creating an object of worker in the manager class, right? So now this class is not tightly coupled with, now manager class is not tightly coupled with this class, right? So now it is loosely coupled, which is a better design, and we are able to set this dependency using this setter method, right? So if I can explain with the diagram, uh, just wait for it. So now in the manager class, we have an object of worker, which is the base class, which is the abstraction layer, and this worker has two implementations. One is simple worker and one is super worker, right? Okay. And we have a setter method that can change the worker. So initially, the high level module was depending directly on low level module. Like manager had an instance of simple worker or super worker, but right now, both of them, I mean, the high level module is depending on an abstraction layer called worker. And also these two classes like simple worker, I mean, this low level module are also dependent on the abstraction layer. So if you can see this arrow thing, initially it was from up to down. Now it is from down to up, right? So we have so basically the dependency has inverted, right? Initially it was from up to down. Currently it is from down to up, right? So dependency has inverted, right? That's why it's called dependency inversion. And the benefit is it makes our code loosely coupled, which makes our code easily maintainable, easily testable, right? And there's one more term which is used with this thing is called dependency injection. Like manager has a dependency on worker, so how we can inject that dependency? So to inject that dependency, we have one method called setter method. So using that setter method, we are injecting that dependency. So that is called dependency injection. Okay. We can also set that dependency with the help of constructor. But here we are using a setter method that can set that dependency, that can inject that dependency. So this is about dependency inversion and dependency injection. Let me know if it's a little complex. So like some of you might not be able to understand this. That is fine. So now I can start with the. Uh, I can start with the. I think I'm audible. Okay. Mohammed, yes, it's true that yeah, in the main, I mean, the main class is tightly coupled with the worker class, but we are talking about the manager class. So manager class is right now it's not dependent on the uh, worker class, right? So that's why it is loosely coupled. Okay. Okay. Now let me start with the design patterns. Look like some of you could not understand this thing. Okay, great. Uh, okay. Now we will start with this thing, design patterns. So, okay. So basically in OOD, we have some patterns which can help us to solve some common problems, right? Like let's say if the problem is to notify a lot of users, a lot of other objects, in that case we have a pattern like observer, which can help us to design a system like that, in which we can have a publisher, we can have multiple subscribers. Similarly, if we want to build a lot of objects, if we want to create a lot of object, in that case we have patterns like factory pattern. So we have some patterns that can be applied to some of the common problems which occur very often, right? So to solve those common problems, we have some patterns which are reusable, uh, which are modified. So again, these patterns are not fixed. We can take the idea of those patterns and we can modify them. We can customize them according to our use case, right? But the basic intention, the basic idea will be same, right? So basically, to design something, we might have to use some patterns. We might have to use some uh, I would say some rules that can help us to make our design better. So it's nothing but it's a some set of rules or some set of guidelines, some set of best practices which can solve some common problems, right? So that's the idea. So basically, initially when developers solve some common problems, so they designed some patterns for us so that we don't have to, face those problems again. We can simply use these patterns to uh, overcome those problems, right? So these are best practices that can help us in many ways, right? Okay. And also the good thing is that let's say if you are talking to your teammate, or let's say if you are discussing something uh, with your team, or let's say if you are documenting something, let's say if you are documenting design of a system, right? In that case, if you can use some common terms that can be used to communicate your idea, right? So let's say if the let's say if all the developers know those things, like they know like what is facade, they know what is builder pattern, they know what is observer, they know what is a strategy pattern. If all of those developers are aware of those terms, then you can communicate your thought process, you can communicate your design with the help of those patterns, right? So to understand the language of architect, to understand the or to communicate to the software architect, we need to know these terms like, okay, what is the meaning of facade, how and why we need facade pattern, what is the use of visitor pattern, when we should apply builder pattern. So there are many patterns, and if we know about them, then we can apply them to solve some common problems. So that's the idea. There are many patterns. There are more than 20 patterns which are very common. Again, we can't discuss everything. So the idea is I'll start with the basic one, the very basic one, which is the simple. Uh, so let me see like how a simple factory can solve a problem and how we can write some code for simple factory. I hope I'm audible and everything is fine till now. Yeah, I didn't, Omkar, I didn't talk about IOC. So sorry, looks like some of you were not able to understand that thing. So that's why I can discuss about IOC in the end. Not really. Yes. Now let me talk about the factory. It's very simple pattern, and that's why I want to start with a simple factory. So in fact, in the factory pattern, we have three patterns. One is simple factory, one is factory method, and one is abstract factory. So we have three patterns within the factory pattern, but I'm going to start with the simple factory because it's very easy to understand. Okay. Let's see one use case and let's see how what is the issue with uh, without using this pattern, and how it will help us to fix something. So let me show you some code. Let's say, yeah, so let's say I have animal based class and I have classes like cat and dog and lion and some other animals. Let's say I have another class called class uh, client one. Client one wants to do something with the animal. Let's say client one wants to use some objects of animal, right? So it will have an object of animal. Let's say we have one method called initialize. Or let's say, okay, let's say the method can be create animal or something. And in the input, we can pass something like, let's say, type. Basically, let's say the type is cat. In that case, I want to create uh, a cat. What I can do is I can simply write if animal type equal to, what I can do is I can simply initialize that animal object with. Similarly, if let's say if the animal type is uh, animal type is a string, if that animal type is equal to dog, in that case I'll initialize that animal object with. Similarly, if we have when the animal type is, let's say, lion, in that case I'll initialize with lion. I have one more class, client 2, which will have very similar code. Okay, let's say client 2 also wants to use some animal or a single animal, right? So let's say we'll have very similar code like this. Again, let's say client 2 is much different from client 1. Like let's say client 1 can, let's say client 1 is doing some research on animals, right? So let's say it is for research purpose. So what I'm saying is that client 1 and client 2 are not similar, they are different. So we can't have a single base class. Like we can't use a single parent class for both the clients. Basically, they are different, right? So let's say they are doing something with animal for research purpose. And let's say this client is doing something with animals just for fun or something. Again, we'll have some lot of code, like we'll have some code where we'll be doing something with animals, or we'll be using that animal object, right? We'll have a lot of code. Let's not talk about other things. Here also we have, I mean, we are initializing that animal by the animal type, right? So in the main method, if I can show you, you can ignore all these things. So what we can do is, let's say we can simply create, let's say, find one object, and someone can call this method like client one dot, and I can pass cat, right? So basically, the animal within client one will be initialized with cat, right? So can you figure out the issue with the code? Like, what is the issue with the current code? What is missing, or what is issue if you're writing code like this? So can you find any issue with uh, the code? Like, what's wrong with the current design? Okay, the one thing is we are getting a lot of we are getting okay a lot of time. Multiple object picture. Okay. Yeah. The one thing is same piece of code. Okay. Yeah. The one obvious issue is we are like both the clients are using the same code, so we are duplicating the code. Any other issue? So the main issue is, let's say if I'm changing the constructor, or let's say if I'm changing one more animal type, right? In that case, let's say if I'm going to add one more element animal like elephant, right? In that I'll have to change this class, like client one, client two as well. I'll have to write one more if else if condition. I'll check else if this, sorry, the animal type is equal to, in that case we'll have to create the animal object, right? Basically, if we are adding one more type of animal, we are changing the code in client one, the client two. That means it's not a good design, right? And the second thing is we are duplicating the code. We are writing the code here. I mean, we are writing the same code here, and we're writing the same code here. The third issue is if we are changing the constructor, like here we are creating the cat object, right? I'm creating the cat object. So let's say if there is a change in the constructor of cat, we'll have to change this code, right? So we have multiple issues. The one issue is duplication of code. Second issue is this client one is tightly coupled with cat1 cat, because if we are changing the constructor of cat, we'll have to change this class as well, client1 and client2, both these classes. The third issue is if we are adding one more type of animal, in that case we'll have to uh, we'll have to change this code. We'll have to change the code of client1 and client2. Ideally, if we are creating a new type of animal, in that case there should not be any change in client1 or client2, right? The code should be same. So that change should not affect this client1 or client2. So this is what can be solved by factory pattern, simple factory pattern, right? So instead of all these things, what we can have is we can have one class which will be responsible for creating animals. So we can have a class called animal factory, and here we can have a public method called, so let me copy that code. Uh, yes, it will return an animal object. So we return that object. Now we'll have all these things at a single place. Okay. Now I'll not be, writing the code here. I'll not be writing the same code here. And again, the client 2 and client 1 will not depend on animal. So what we can do is we can, let's say we have the same method called, we can do is we can simply, so we'll have an object of animal factory. We'll have an object of animal factory. With the help of that factory, of course, we can have a setter method. That is what we learned in the dependency inversion and dependency injection. So we can have a setter method, set factory, with the help of which we can easily set the animal. I mean, set the factory. How I can initialize this thing, and then I can simply call this method to initialize my animal of for client 1 or client 2. Factory dot create, and I can simply pass that type. We are getting from let me copy the same code in client 1, because we'll have a lot of code in client 1 which will be different, but for the this okay. So here you can see if, but we are not creating animal object within this class, within the client 1 or client 2. So the first thing is we are not duplicating the code. The second, we are adding one more element, animal like elephant or hippopotamus or rhinoceros or anything, right? Any animal. In that case, we'll not be changing the code of client 1 or client 2. Of course, we need to change this code, but we'll need to change only this code. We'll have to write only. I mean, we'll have to modify this method. We'll have to add one more if else condition if we are adding one more type of animal. But the client 1 or the client 2 or many classes which will be using the client object, I mean the animal object, will be unaffected, right? So when we are adding one more type of animal, this class is not being affected at all, which is a good thing, which means they are loosely coupled, right? So factory is helping us to make our design better by removing the duplicate code, by making our code modular, by making our code maintainable, because the classes are loosely coupled, right? And we have one class which is responsible for creating something. So this is the simple example of simple factory. I hope you got the issue with the design. I hope you got like how this pattern is helping us to write a better code. Uh, how to choose between factory pattern and dependency injection? We're using both, right? We're using both of them here. Uh, so anyone who could not understand like how factory is helpful? Yes, this is similar to higher order function in JavaScript. Yeah. So I mean, this thing is a part of dependency injection, because again, this client is a high-level module which is using a low-level module called animal. So to inject that dependency, or again, we are using this one more low-level class called factory, and we are injecting that dependency with the help of this setter method. So here we are using dependency inversion plus dependency injection. Um, okay, how factory is different from dependency inversion? See, the purpose of factory is to solve the problem of object creation, right? Yes, that. So we shall. Okay. So we should, I mean, design our classes. We should write code in such a way that our code can easily be modified for the future changes, right? So like, let's say in this code, if we are going to add one more animal class like elephant, I I need to change only one class called uh, animal factory. Otherwise, other classes will be same, right? Okay. I don't need to change this class. I don't need to change line 2 class. So these classes will be unaffected. But yes, we'll have to change the factory class because we have added one more type of animal called elephant. So the simple use of factory pattern is if we need to create multiple types of objects, uh, and again, if there are many clients, there are many classes which will be creating that object. Like here, animal is being created by client one, by client two, by many other clients, or by many other classes. In that case, we should use this pattern. The pros is, it makes our code maintainable. It's a better design. The cons is, uh, again, we are writing a class, a separate class, which is doing the creation thing, right? So basically, we are adding extra code. So that is a cons. Like sometimes this is not required. Like we can simply initialize a class by writing the new object, I mean the new keyword, right? But here we are creating a separate class which will be creating the object. So it is increasing the number of classes in our system. So that is the one cons. Otherwise, there's no cons in the factory, simple factory. Okay, can please. Okay. Uh, okay, the one question from Thompson is this can be done using dependency injection. So why we are using factory pattern? See, this thing can't be done using Okay, I got your problem. See, here the idea was I want to initialize this animal object with uh, by the given type, right? Okay. So let's say if we have something like this, in that case we should go with the factory pattern. I agree that it can be done with the dependency injection, but in dependency injection we don't have a common method. We have to write a method like uh, okay. So in dependency injection, to inject the dependency of factory, we'll have to provide a method called set animal method, and in that method we'll have to provide the animal object, right? But how we can create that animal object? That's the point. To create the animal object, again, there should be some class which will be doing that, and so that class will be tightly coupled with the animal class, right? So that's why if a class like animal factory can take that responsibility of creating that animal object, different types of animal object, in that case other classes will not be dependent on the animal class. Okay. So that's how it is useful. uh, the one question from Pranav is Spring Boot or Node.js. See, okay, the good thing is, I mean, if you search jobs on LinkedIn, if you're a backend developer, if you know Spring Boot or Node.js or any backend technology like Ruby on Rails or Django, things are quite similar, right? Like the concept of REST API, the concept of databases, the concept of ORM will be same. So if you know any backend framework like Spring Boot or Node.js, you can get a backend job. It won't take much time from when switching from one to next one. Yes, factory is more suitable in inheritance. Yeah, that's correct. The application is okay. So so tomorrow we'll solve some questions, some interview questions, and we'll see like okay how we can apply this principle, these patterns to solve some uh, actual problem of interview. Right. So we'll do that. Okay. Let me quickly talk about one more pattern called facade, and then we'll be done with then we'll have some QA things. The last one is facade. Let me quickly talk about like what is facade pattern and how it is useful. Okay, there is one book called, I don't know if you have heard that name or not. So there's a really good book called Hate First Design Pattern. So I'm going to use the example given in that book, Hate First Design Pattern. Uh, it's a really good book for design patterns, right? So the use case is that let's say uh, you want to set up things for home theater, right? So home theater means like you will have I mean you can dim your lights, you can start the amplifier, you can start the CD player, you can start the projector, so let's say you have one class projector which will be doing the projection thing, then you will have a one class for CD player, then you will have one class for let's say popcorn popper. Like let's say you want to eat popcorn while watching the movie, right? So let's say you have one popper or something. So you know all the classes which will be doing all these things. Like you will have light class with the help of which you can like light class can have a method called dim lights which will dim the light. Then you can on the CD player. Then you can insert one CD player of that given movie. Right, then you can have things like amplifier, then soundbox, soundtrack, and there can be multiple classes which will be doing multiple things, right? So let's say to start watching movie, let's say there's one task called start watching movie, right? Or let's say the one method is start a movie, right? So in that case, you will have to do multiple things. Like you will have to call dim light methods of light class. You'll have to call start popcorn popper method of popcorn popper. You'll have to start on method of CD player. You'll have to start insert a disk in the CD player. You'll have to call project.start method, right? So you'll have to call multiple methods, right? In that case, let me plug in my charger. It's like the battery is down. Just wait. Okay. So, hmm. So basically, to start watching movie, let's say if I'm a client and I want to start watching movies, right? In that case, I'll have to call these methods one by one. So the client will have to interact with multiple objects one by one, and the clients will have to call these methods one by one, right? So client will have to write a lot of code, right? So if we are designing things like this, in that case, it will be tough to write a code for client to use some features of your system, right? Like let's say if you're designing home theater system, and if you're designing classes like this, that's a really bad design because the client will have to invoke those methods one by one. So your client is interacting with a lot of objects, and the client will have to remember all those methods so that they can call all those methods one by one. So let's see how Facade can help us, right? So if you're using Facade, so okay, so the idea of Facade is like here we can have a single class called home theater, right? And within that class we can have objects of all those things. Like we can have an object of CD player, we can have an object of popcorn popper, we can have an object of amplifier, we can have an object of projector, we can have an object of light, right? So basically within a single object we can have, let's say, all these things. I mean, within this class all these are fields of that class, right? And let's say this class has a method called start watching movie or something, right? Now the client will interact with only this object called home theater, and the client will just call a single method called start watching movies, right? And if and now the client is not directly interacting with all these objects one by one. The client is interacting with a single object called home theater facade object, right? And this facade object is forwarding or delegating, like let's say the okay, so let's say in the start watching method, what we are doing is we can simply invoke a method like popper dot start or projector dot start, right? So basically we will be invoking all these methods one by one within that single method. So now the client will call that single method, and all these methods are being called by facade class, right? Within that method. So now it's easier for the client to use this system because client will have to invoke only single method, right? Which will make easy to use for the client, right? So that is the simple example of facade. So the simple idea of facade is if a client or anyone will have to interact with multiple objects one by one, right? In that case, to simplify the complexity of the system, what we can do is we can have a single class, and that class can have all these objects, okay? And now the client will interact with that single object called facade object, and the facade object will hide all the complexities. It's like an abstraction layer because client will not be aware of like, okay, which CD player is being called or what is the order of those methods. So basically we are hiding the complexity, we are hiding the details with the help of the facade class, right? Okay, so facade class is hiding the complexity. It is making the code for client, easy to use, right? And okay, and so basically the client is not directly interacting with all those objects one by one. The client is interacting with a single object called facade object, and the facade object is forwarding or invoking those methods of those objects one by one. Okay, so that is the basic idea of facade. I hope you got the specific example? Okay. Yeah, I'll talk about one more example that might help you. Facade is used in layer architecture, right? So, Kishita, first, okay, so facade is for, okay, let me explain facade with one more example. That might help you. So, let's say, I hope all of you have used Paytm. Okay. Right. So, let's say Uber wants to integrate with Paytm, right? So, let's say if a user is riding with Uber, then you can pay the amount using Paytm, right? So, there is one API called send money. Well, there's one method. Let's say this is a class, packing class, and there's a method called send money. Let's say within that Paytm class, so let's say there are classes like wallet class, which will be doing the wallet task. There's a SMS class, which will be sending the SMS. There's an email class, which will be sending the email, right? Let's say this is the Android app. This is the client for this backend service. So this Android app, basically you want to send, let's say a user wants to send money to another user. So the one way could be the client can do all the tasks one by one. Like the client can, let's say there's one method called uh, deduct money. So I'll call that method to deduct money from sender's wallet. There's one more method called add money, which will be called to add money to the receiver's wallet. Then once transaction is done, we need to send SMS and email to uh, users which are part of that transaction. So we'll have to call a method called send SMS. We'll have to call a method called send email, right? So the one way could be that this client, this Android app can call all these methods. So in web service, these methods are called APIs, right? So the client will have to call all those APIs one by one, right? Uh, okay, so it's not a good design, right? So instead of calling all those methods one by one, what we can do is we should have a single method, single API called send money, and within the same API, we can do all these things. Like we can do deduction of money from sender's wallet, addition of money to receiver's wallet, sending SMS, sending email, right? So we have a single method for client. So the Android app or iOS app can call that single method called send money, and within the send money, we are doing all these things. Like we are calling the wallet object to deduct money of sender. Will call again that wallet object to this thing. Will call SMS object to send the SMS. Will call email object to send the email. Right. So that's how while designing APIs or while designing a system or while designing anything, you need to use. You will have to use Facade very well so that your clients can interact with your system easily. If clients will have to call each method one by one, that's not a good design. You should hide all these things uh, with the help of a layer, right? So if you have worked on backend, then you can understand this example easily. Uh, okay, so anyone who could not understand like what is facade and how it is useful for us? Irfan, yes, facade is similar to layered architecture. I mean, in layered architecture, we use facade pattern, so they are similar. Yes, facade adds a layer of abstraction. So, uh, yes, I mean, in facade, you use abstraction, or we add an abstraction layer with the help of a facade so that clients can be unaware of the complexity of our internal system. Okay, great. So tomorrow we'll discuss some questions. So I'll discuss one more pattern called flyweight, and then we'll solve some LLD interview questions, and we'll also talk about like how you should tackle these questions in the interview. Okay. So Yash, are you there? Okay. So now,
Yeah,
okay, let me. Okay. So now
that
Yash
that
will.
was a really good session, Mr. Shashi, and I think everybody enjoyed it. So we have a lot of users who attended the whole session, and they would definitely have learned a lot of things about ODL. So how was it, guys? Shoot your response in the comments. We would really like to know how did you like the session. Okay. So, guys, we have launched Geeks for Geeks Premium. So, Geeks for Geeks Premium is a product for those who are computer science enthusiasts. So, we offer really good features in the premium, and I will just showcase all of them to you for once. Just give me a second. Okay, so here goes Geeks for Geeks Premium. So you get an ad-free experience of Geeks for Geeks. Guys, no annoying ads at all. You get zero ads, just the content you like. And that too in a very premium feel. We have enriched our user experience and UI for the same. Secondly, there is doubt assistance in Premium Plus model as well. So you get doubt assistance on all practice questions that are there on the practice portal, and you get the response. You get the solution for every doubt you get on any problem on the practice portal. You get an editor's choice newsletter. Okay, so sometimes it gets really tough, like whether what article should you read or where should you begin. So here are editor's choice newsletter. Here, the top handpicked articles for you, right from industry experts, and you will get it in your mail. So it will get really easy for you. And what is the best part? You get free access to jobs portal. Okay, so you even get jobs, like if you're good at programming, but you don't have any access to good companies, then Geeks for Geeks is there for you. Okay, finally you get to write personal notes on this. Okay, you get to write personal notes on any article. You can write your notes, like if you are feeling that you need to save something right now with which you can recall later, so you can do that for sure. Okay, so there are two plans, Premium and Premium Plus. Why I am discussing this right now? The reason is that this I'm announcing a huge giveaway. Okay, so there is a link. There's a post on LinkedIn that we will be sharing on right away, and we are offering free access to Geeks for Geeks Premium for whole 1 year, and guys, it will be amazing. It will be a wonderful experience for all of you. Okay, so head to our LinkedIn page and go there, and you will find a post on the same. Just tag your friends and share it among your friends, and we will definitely pick someone, and we will announce the winner tomorrow. We will be announcing the winner tomorrow, so make sure you are here and to see who has won the free giveaway. The link, the yeah, Bhavya is asking for the link. There is no link for the giveaway. You have to head to our LinkedIn page on. You have to head to our page on LinkedIn, and there will be a post for the same. Okay, I hope you guys enjoyed the session. We really loved to have you on board. So looking forward to our rest of the session tomorrow. Okay, bye guys. Take care. and stay safe, which is most important these days. Certification. Okay, so we are planning to send you the certificates for the same, but there is no guaranteed time. It can take up to 10 days for us to send the certificates since there are many users. We will also share the link for the certificates tomorrow. Okay, so bye guys, take care.